we talked about how to find volume when we rotate around the x-axis or the y-axis, right? But now, what if we have to rotate about a line other than the x-axis or the y-axis, right? So suppose, for example, you have to rotate about, an arbitrary line, like y equals -2, right? So this region here, instead of rotating it about the x-axis, what if you now had to rotate it about the line y equals 2? Now, first thing you have to do is you have to think, the line that you're rotating, is it parallel to the x-axis or the y-axis, right? This y equals -2 is parallel to the x-axis, so you're going to be integrating with respect to x and dx and all that stuff, okay? So that's first. Now, second, right, so the way this looks now is when you rotate, it's going to almost look like this, right? Like this. So the way the discs will look is you've got one disc here. Sorry, it's further down. Okay, you've got one disc here. Okay, this is the upper disc, and then you've got another disc here. This is the lower disc. Okay, so now think about this for a minute. The radius, let me erase this so we're just looking at one. The radius now is from here all the way up there. Okay? Now, do you see how the radius is bigger than if we had rotated around the x-axis? Okay. The distance from the graph to the x-axis, that's your y, right? That's your equation. But in addition to that, we're also gaining some additional distance from the x-axis down to the line. All right? Down to the line. And so what we're going to do is we're going to have the y, okay, minus -2, right? So let's see if that makes sense. Does it make sense that that line is the y value minus -2? Well, yeah, because then we're going to have y plus 2, and that totally makes sense, right? I have a distance of y plus a distance of 2, all right? And so that's how that's going to look. So that's the theory, the concept behind it. So let's talk about where the line of rotation lies. If the line of rotation is below the region to be rotated, then each radius is the upper minus the lower, meaning big R is the outside curve minus the line, and little r is the inside curve minus the line. So let's go ahead and do this one. I'll take questions later. Let's go ahead and do this one. We're going to rotate this region. Okay, so what we have here is y equals root x plus 2, and y equals e to the x, and it's going to be rotated about the line y equals -2. Okay? So, again, the area that we're rotating, right? So the bigger disk is this blue here, and we just said from the x-axis above, that's y, that's the function, minus this distance here, so minus -2, that ends up adding a space of 2 to our radius. So we're good on that one. Okay, so for here, the big radius is going to be the square root of x plus 2 minus negative 2. And so that, in fact, is the square root of x plus 2 plus 2. Okay, the little radius. Okay, the little radius. This distance here from the x-axis to the graph is e to the x. So for the little radius, we're going to do e to the x minus negative 2. So now think about it, distance-wise, this is e to the x plus 2. Does that make sense? Distance-wise, right? E to the x plus a distance of 2. Yes, it does make sense. Okay. So, okay, that's what we're going to talk about right now. Just a second. So for this one, I have this, and I have this, right? So let's call this, you know, A comma C, and we're going to call this B comma D, and I'm doing like that for a reason. So let's write the integration, first of all. This is going to be the big radius, the square root of x plus 2 squared minus the little radius, and there's a pi out front, dx, right? So pi r squared minus r squared. And now, this is one where you would be given a calculator, so you would plug it in the calculator and get the points. And so what you do is you store this left point as A, store the right point as B, and then we go from A to B, blah, blah, blah. My point today is to set up the integrals, and then this one, you know, you would have to like plug in and get it on the calculator. Okay, Henry, then Eli.
Well, you do
The line of rotation is above the region to be rotated. Okay? Right? Is that what you have next? Yeah, okay. So, remember, each radius has to be upper minus lower. So, if the line that you're rotating above is above your graphs, then it has to be upper minus lower, meaning big R is the line minus the outside curve. Little r is the line minus the inside curve. What do I mean by that? Here are the same exact equations that we've come to know and love from before. Now we're going to rotate around the line y equals 2. Y equals 2 is here. Okay. Now, if I'm rotating around this, right, then think of the radius as being from the line to the graph, that's one radius, and then the line to the other graph, that's the other radius. Now in this case, big R is the red, right? So again, it doesn't change from what we were doing before. That radius, right, generic radius is upper minus lower. Now, radius is upper, the line, minus lower. So 2 minus e to the x. Okay? Little r is upper minus lower now for the blue. So 2 minus the square root of x plus 2. This is perhaps like, you know, the tougher part. And then after that, it's all about, you know, just the integrating. So now, to integrate, again, we're going to do the same thing. So this is A comma C, B comma D. Because the line that we're rotating around is parallel to the x-axis, this is all with respect to x. So we're going to go from A to B, pi, big R squared minus little r squared. Big R is 2 minus e to the x squared minus little r squared dx, and that's that. Okay. Okay, now left or right, okay? So, what if the line of rotation is to the left of the region to be rotated? Again, our radius has to be, in general, right? It was the larger, so right minus left, remember? Right minus left. So now, if the line is to the left of what your of where your functions are, so if we're doing right minus left, it's got to be function minus the line. So let's take a look at this example. We have the region bounded by x equals y squared minus 2 and x equals ln of y, right? So this is x equals ln of y, and then the blue is x equals y squared minus 2. We're rotating around the line y equals -3. Okay, so I have two radii here. I have the red radius and I have the blue radius. Okay, so let's take each of the radii separately. If I want the red radius, that's capital R, right? Then it has to be always the line, I'm sorry, not the line, the outer function minus the line, right? Larger minus smaller, positive minus negative. So capital R is ln of y minus -3. Okay, does that make sense? Right, ln of y plus 3. So the distance, that's ln of y plus another 3. Okay, and then little r, again, it has to go right minus left. So function minus line. Y squared minus 2 minus -3, y squared plus 1. Any questions on this? Okay, so we're going to be integrating now. Okay, so this is a comma c, b comma d. Okay, so we're going to integrate because this is vertical that we're rotating against. It's like the y-axis. We integrate with respect to y, and so we get ln of y plus 3 squared minus y squared plus 1 squared, pi out here, dy, but now we got to go from what to what? C to D.
Oh, because it's called y. So
it's with respect to y.
But it doesn't actually matter what variables you put.
No, it doesn't matter.
As long as you do the y, you have to do the y coordinates.
Yeah.
You have to be well defined though. Like your variables have to be well defined.
Mistaken if you're using A and B as both x's and y's for different equations.
Normally the convention is, yeah, A and B is like the x values and C and D are the y values. Okay, so if the line is to the right of the region to be rotated, so look at this one. We're rotating around x equals 2. If I'm rotating around x equals 2, all right, now I have a little radius and I have a big radius. And if radius is always right minus left, then big R is 2 minus, what was it? Y squared minus 2. So this line, this is y squared minus 2 equals x. And then the red one is x equals ln of y. So the little r is 2 minus ln of y. So if we simplify this, it's 4 minus y squared. So now, to integrate to find the volume, right, it's pi r squared So pi, big R, squared, minus little r, squared, dy, from C to D again. Again, identify that this is AB, and this is CD. All right? Okay. This is kind of like a big deal. And it, so, you know, we need to get as much practice with this as possible.